GCSE Physics boosters, stars like our Sun. We're going to look at the life cycle of a star like our Sun. In the next video, we'll look at much bigger, heavier stars. So now this is a cloud of dust and gas, mostly hydrogen, and it's called a nebula. And in the Milky Way and in other galaxies, there are these clouds, and they are what's left over after a giant star has exploded. Okay, when a very, very large star reaches the end of its life, it explodes in a supernova. And you're left with this big cloud of gas and dust, mostly hydrogen. Now, what happens is that gravity causes the gas to clump together into like balls of gas. I mean, massive, massive, massive balls of gas. It might be started by some kind of a shock wave, might actually initiate it. It's a bit complicated, but just remember that gravity starts to clump it together. It starts to come together into balls of gas. So let's have a look at one of these clumps of gas, this massive ball of hydrogen. Now, gravity is going to pull it together. It's going to get smaller and smaller. The pressure will get bigger and bigger, and it will get hotter and hotter and hotter. Okay, eventually it'll become what we call a protostar. Now, it's not actually a star yet because fusion hasn't started. Okay, it's not quite hot enough for fusion to start. If it's not big enough, if its mass isn't big enough, then fusion will never start, and you'll just end up with a smouldering hot ball of gas, which we call a brown dwarf. Okay, but if it is big enough, if it does get hot enough, then at one point fusion starts and it switches on like a light bulb. Okay, and we get a main sequence star like our Sun. Fusion has started and hydrogen is fusing to form helium, and we have a proper star. Now, our Sun is a main sequence star, and it is balanced. Now, balanced as in there's forces pushing outwards, there's a fusion bomb happening in the middle, so there's massive forces pushing outwards. It's an explosion, but then you've got gravity pulling inwards, and these two forces pushing out and pulling in are balanced. Our Sun is about 5 billion years old. It's got about another 5 billion years to go, and it's a main sequence star, so it will be balanced for a long time. However, it won't be balanced forever. Why not? Because eventually the hydrogen in the core will start to run out. And what happens when that happens is that the core starts to expand as fusion starts spreading outwards. So it was just happening in the core, which is very, very hot, about 15 million degrees. But now fusion is spreading outwards and it's burning hydrogen further out from the core. The core gets hotter and hotter. The star starts to expand. It starts to blow up like a balloon. And also you start to get heavier elements formed. Not just helium, but you start to get carbon and nitrogen and some of the smaller elements forming as well, fusing together. The Sun becomes a red giant. It expands until it becomes very, very big, about the size of the orbit of the Earth. Although, I mean, before that happens, the Earth would have been completely frazzled by then. It would have lost its atmosphere. Maybe we won't be there by then. The Sun will be many, many times the size it is now. If you look at this picture, there's the Sun now, and there's the Sun as a red giant. Okay, many times its size now. What happens next is that on the outer layers of the Sun, because the Sun is so big, the gravity is actually a lot weaker around the outer layers, and the sun starts to lose its atmosphere. It loses its outer layers, and it's like blowing smoke rings. It loses a layer, then it shrinks, then it gets hotter and it expands again. It loses another layer, and then it shrinks, it gets hotter and it expands again. It loses another layer, and basically the sun is losing its atmosphere. And eventually it will lose all of its atmosphere, and you're just left with the core, and the core will shrink and become something very, very bright, very hot, very dense, and we call that a white dwarf. So a white dwarf is the exposed core. It's the core of the sun which has shrunk and become very small and very hot. Okay? Eventually that will cool down, but that will take a long, long time to cool down. And eventually that will become a very small, dense black dwarf. This is a Hubble Space Telescope picture, and it shows a star like our sun. What will happen eventually to it? You'll end up with these layers of gas, these smoke rings of atmosphere, and at the center there's a white dwarf. Okay, it's actually called a planetary nebula. So remember, what do you need to know? So learn this list: nebula, protostar, main sequence, red giant, white dwarf, black dwarf. Learn that list and be able to describe each one of them, and also say how it goes from one to the other, what changes happen during the cycle. It's likely to be like a big question with loads of marks for it, and you'll have to write like a little essay describing what happens, describe the life cycle of a star like our sun. Loads and loads of marks, so get this learned.